Hello, in this video I would like to test some batteries for this Canon camcorder. The problem was that the stock battery, which is this, only allows to run this thing for about 70 minutes. I wanted to have about 2 hours of runtime without interruptions. So I decided to buy a replacement, which is this. Come on, camera, focus. Alright, so it says for CN, by which they mean replacement for Canon NB-2LH, and it's rated at 1800 milliamp hours. I had my doubts when I bought it on eBay, and I wanted to measure this capacity. Well, why I'm not just turning on my camcorder and putting it on a desk and see how long it runs. It's possible, but it will not give me the measurement in milliamp hours. It will only estimate my runtime. So I decided to do it a little more scientifically. To do that, I need to estimate the current draw from the battery. Okay, I guessed from the fact that this one, let's see if I can capture that. It says 530 milliamp hours typical and 500 milliamp hours minimum. So from the fact that it allows to run this camcorder for about 70 minutes, I guessed that it must be about 400 milliamps, maybe slightly more than that. So I decided to give it a try at 400 milliamps, and for this I am using my electronic load. Okay, so I connect the stuff like this. I'll show you in a second how do I hook it up. Alright, here is my setup. So I have this giant clamp which is holding, pressing two pieces of metal, two pieces of wire. Well, I used pieces of paper clip, really, and this is hooked up to this electronic load. So you see, the load is off right now. It is reading 8.24 volts. I set it to 400 milliamps, and I have this data login in my computer set up, so it's recording timestamp, millivolts, current and power from the instrument. And let me turn it on. Alright, so it's on. So it's reading 3.2 watts. And this is the actual current. This is desired, and this is the actual which is going on right now. Alright, and now we see the data login in the computer is working. So it saves those measurements in a file from which I can analyze stuff later. So I have already run this experiment with the stock battery, And sure enough, it's about 70 minutes or so, so my guess was approximately right. That camera draws about 400 milliamps. It certainly will vary a little. It will depend on brightness of LCD, it will depend on operating the zoom, and some other minor things. So, and then I run this experiment with this Chinese replacement. And let me show you what I found. Okay, first I would like to show you what happened with that stock Canon battery. So I loaded that data using GNU Octave. It's probably overkill for this purpose, but why not? I have it, I know how to use it. Okay, so I read the file, transformed timestamps, so basically I subtracted from all timestamps the first one, which gives me count from 0, then I scaled it to minutes from seconds, and here's the plot. So X is minutes, Y-axis is volts, and so you can see after about 70 minutes it collapsed. And let's have a look what happened to that Chinese replacement thing, which is supposed to last almost 3 times, oh well, even more than 3 times longer. Okay, I loaded data from that experiment, and here is the graph. Wow, it actually took about 90 minutes to discharge this thing at 400 milliamps, which is way less than I expected. So let's do some math. So here is a quick calculation. So this last line, 400 milliamps, 90 minutes, which is 1.5 hours. So if you multiply, it gives about, well, not about, but exactly 600 milliamp hours. And then I decided to try this experiment again with just 200 milliamps. So it lasted 190 minutes, which gives 634 milliamp hours, slightly more because we are going easier on it. Well, and I obviously charged them completely before the experiment. Alright, so I was not satisfied with this because we're supposed to get 1800 milliamp hours, so 3 times more. I wrote about this to the seller and explained what I've done briefly, and they decided to send me a replacement. Let's check it out. Well, before we check it out, let's see how can I tell the batteries apart, if it has any serial number or anything. Let's have a look. I think I see something here which is hard to read on the screen and the camcorder. Let me read it here. That's 326 DK060CN. I don't know what it is, but let's hope it's different on the other battery. So here is the replacement, just arrived, not unpacked yet. Here it is, in a nice box. Let me unpack it. has that plastic cover, very nice. Okay, so here it is. Let's see if I can do it with one hand. It's actually awkward. Okay, cover off. Let's see. Let's have a look at the serial number. Three two six three 2DK060CN. So it's not a serial number, and it's exactly the same as the previous one. Oh well, I'll try not to mix them up. So let's charge it up first. Okay, installed it into camcorder. Charging. So as soon as that blinking stops, it's fully charged. Alright, it's not blinking anymore, fully charged. Let's test it. So it is hooked up to the electronic load. Let's see, it is reading 8.33 volts, set to 400 milliamps. And by the way, I set the minimum voltage to 5 volts just in case, but that's not really necessary because battery has a protection system in it. It probably turns it off even sooner than that. So let's turn it on. Alright, and let's have a look at the data logging. So here it is, keeps recording the data, and so let's look at that later when the experiment finishes. Okay, it's another day. I didn't finish yesterday, it was getting late. So the experiment, that discharging thing, finished, and let's have a look at the results. So I loaded the data, produced a graph, and we can explore the graph when I move my mouse here. You see these numbers change, so we can see exactly the points on the graph. So if we move here, so we see at 5 volts the electronic load switched off, and after which the battery voltage rebounded a little, which it should. Before, by the way, we didn't see this because the battery electronics was shutting it off, and the same thing was happening inside the battery, but we didn't see it outside. It's not essential to our experiment. So what we do see is that it took about 97 minutes to discharge it completely, which is almost the same as before, slightly longer. I mean, almost the same as the other battery, the first one I played with. So let's have a look. So this number 2, battery number 2 at 400 milliamps took 97 minutes to discharge. It gives about 647 milliamp hours, which is still way off that claimed 1800 milliamp hours. So it's like 1/3 of that, almost, slightly more than 1/3. Well, I'm not satisfied at all. It wouldn't run my camcorder for 2 hours as I hoped. If that 1800 figure was true, it should run it for more than 3 hours. Well, I'll bring this up to the attention of the seller, and we'll see what happens. And by the way, I should probably describe a little bit my setup here. I didn't talk about that yesterday, so I'm using Eclipse programming environment and Python to communicate with the instrument, and then as I mentioned, I saved that data into a file, and to analyze that I'm using GNU Octave, which is free and open source equivalent of MATLAB. Yes, as I mentioned, it's probably overkill for this purpose, but why not? And you see, it can easily produce graphs which I can explore, so it works beautifully for me. Alright, so what's the conclusion? I had 2 batteries, and at this point I have my doubts that they were defective. There is a chance, so there are 2 possibilities. Either both are defective somehow, or maybe this 1800 milliamp hours figure is just not true. I don't know what it is. It could be a mistake, it could be a deliberate thing to sell more batteries, and most customers don't know how to check that, even if they feel that it should run the equipment longer, but they don't know how to properly test that. Well, anyway, let me talk to the seller and see what happens. And I really hope this was useful to somebody, and if you like that, well, give it a thumbs up. Thank you very much. Bye.